Hello everyone, I am Rakesh uh, from Teknovate, and today we are presenting Smart Meter Predictive Health Monitoring Platform that we have developed specifically for the discoms. So we have been in smart metering a lot of developments activities for 3G to 4G NIC card, where we have involved in design and development of the NIC card itself. Then we have developed and deployed a lot of AMR solutions for solar and other diverse applications. Then MDS development for MDM class operations for these deployed AMR solutions. And we are also a certified SI partner for one of the public sector AMIs. So with this experience, it led us to build a predictive platform wherein today's discoms are facing a lot of issues in managing and maintaining the smart meters and bill collection. So our platform actually is built on three core concepts. First thing is digital twin. So it maps to its own itself with the proper working parameters, and also it compares itself with existing uh, parameters that has evolved in the situations. And then there is a four-layer intelligence model that we have included. So wherein the first layer is it will compare to its own parameters where it has to be working proper. Second layer is it will be comparing with neighboring meters in the same DTs. Third layer is it will be comparing itself with the DT meter, and the end layer, fourth layer is going to be a correlation layer wherein AI and everything is going to come in the picture. So basically, how this thing is achieved, we'll be doing analytics, AI, and domain rules. So this will derive MHI, and we have achieved an accuracy of greater than 95% with events, logs, and load profile and daily profiles, daily load profiles, up to 95% of accuracy. So here in what we can say is that we can exactly pinpoint this is the issue with the meters and exactly guide the field operators to go and visit these sites in case if it is required, and to do these corrections. Okay, this entire stack is built in Python and Python's ecosystem, and it's a SQL database, and it is very easily scalable. It can be scaled to about more than 15 to 20 lakhs meters, and more than that we can exactly spawn multiple virtual machines for multiple discoms, and in singular dashboard can be presented. So this is a operations ready dashboard that we have. So this is how the smart meter predictive health monitoring dashboard looks like. So the moment you log in, you will get visuals like this. So these are some of the numbers here. You will see that there are some critical meters, degrading meters, watch meters, and optimally fully healthy meters. So this is something we see a term called as MHI here. MHI is meter health index. Now this entire analytics has happened with three logs. One is IS 15959 event logs. Second one is block load profile, and the third one is daily load profiles. Okay, so there will be a unified meter index verdict. So that we call it as MHI, meter health index. So using these indices, we are going to segregate each and every meter onto critical, either degradation, watch, and optimal, based on how many numbers these meters are categorized into. And also this average that you see is the entire average that you see for the fleet. So apart from this, you can also see the focus areas of this. So this is a wrong insulation focus, and overcurrent stress. This is another focus where you see filtered out only meters that are high current. And similarly, there is a loose contact focus wherein meters having a lot of loose contacts in their connections, where you can, it's very much evident that these analysis I will show later on. Then there is a meter damages that might happen due to over voltage. So there are about 51 meters like that. And eventually there are some other meters, about 18,000 ones that might eventually fail because of some other reasons. Okay, even that also I can show that. And there is also a clear cut case of RTC clock drift. This also I will show in the demo as a later on. There is some kind of a visual intelligence board here, total MHI distribution band. So optimal meters are about 21,638 meters and so on and so forth. And signal source contribution is major contribution to the signal source is because of the events. Events are the one of the high priority where the meter itself has reported that I have such so and so problems. BLP is the block loader profile, wherein the meters logs are there, and this comes only after the analytics and machine learning and AI models. Now, similarly, DLP also is the same thing, wherein the daily load profile of the meter, these have to be analyzed. And how are the source combination and what kind of priority has to be taken? This is where the visualization chart comes into picture. And this is where the event top event signals. So you can see the top event somewhere around 37,000 meters have reported that they have severe phase sequence reverse. So this is kind of a very commonly occurring issue events that the meter has reported. Meters in the entire fleet has reported. And there is a Y phase current reverse, B phase current reverse, and so on and so forth. And there are some of the tamper cases wherein CT opens are there. You can see here. So going further down, there is event diagnosis with daily reading signals. So this is a combinational aspect wherein multiple events and multiple signals from the DLP and BLP, they are combined. So this is where the analytics happen, and these are all the analytical signals and combinations that are happening. So if you can see here, if you want to drill down into much deeper aspects like event intelligence and load profile intelligence and even the daily read intelligence, you can see there are direct links over here. So this is how we are going to use it. So if you can see, there are smart meter predictive health monitoring dashboard that you can see here, and you'll be seeing these kind of visuals. So these are all the labels where you can directly jump into how to use it. So if you can see here, I'll just go to the critical part. This is critical 151 meters are there. Just I'll click on that to these meters where these meters are very critical. So you can see the MHI index of that particular meter. So you can see it is about 39 out of 100. Okay. So now you can see there are some lines here. So this is kVARH of the meter. That is pretty much normal. And you can see the voltage is kind of varying between 250 and 240. And there is one condition here wherein the cumulative kWh is reversed actually. Okay, this is a major flag where the revenue actually is going down, and this is a case of clear tamper kind of a thing. Okay, so this can be verified in the event evidence. You can see that R phase CT is open, and phase sequence reversal is a wrong installation, but that is also true. And this is a clear case of tampering. And you can see the KWH reversal also in this DLP evidence. Okay, so here the reading, cumulative reading has come from 1 to 3 to 4 and again back to 0. Okay, it's a clear case of tampering. So as you can see in these evidences actually there is an option to share this email directly. So you just click on this and you type and you can send it. The email will go right away. And in this thing here, there will be multiple things that are included in this. So it will give the proof as to what is happening. Okay, and there is a kappa, corrective action and preventive action. So also for it is also been translated into the regional language. Yes. Okay, and also there is a priority and prevention, what has to be done and what are the clear cases has to be done. So all these things are clearly listed out. So let's take another case here. Let's say, for example, there are a lot of shortcuts that have been provided here. So instead of you going and filtering out these meters, a lot of shortcuts have been given here. So I will just try to see overcurrent risk here. So as you can see, there are a lot of meters here wherein it's having a overcurrent. So you can see here in the graph the current basically has gone more than 75 amps. Okay, so these are the things because meter so anything above 50 amps, meter might get damaged during the course of time. So the same can be verified in the evidence here. So in the raw rows, evidence rows, you can see that these many current instances have come 70, 74, 75 amps. So it's a clear indicative that meter might go bad. So there is no other cases of tamper or anything in this case here. And as you can see, the kappa is also clearly listed out here. Check the connected load and verify consumer sanctioned load and all that. So it is a case wherein consumer might be consuming extra, load and all those things. Okay. There is, you can also see there are some loose contacts you can find out. Okay. So these loose contacts of the meter, let's say you can see there are some meters here. So these come under the watch. So loose contacts are typically wherein whenever the voltages fluctuate immediately between very less, that is less than 10 volts, to immediately to back to normal, that is 230 volts. So sometimes this fluctuation happens and these are all flagged as loose contacts. If there is a loose contact, sometimes the current will come, power will be there, and there will be a power will go away, and it is momentary. It keeps on happening over and over the period of time. So those patterns are actually analyzed and they are all flagged. So if you can see here, see suddenly this voltage has gone to zero all of a sudden, and suddenly all the parameters have come back to normal. So this pattern is there actually not many times. So if you can see here also, like a lot of suddenly voltage is going less than 5-10 volts like that. So if you can see, these are the evidence cases where the terminal can be loose. Yes, so it has clearly flagged that this is a loose contact suspected. Intermittent voltages are found out. So maximum current is 1.85, maximum watt hour is so much. And then you can see the proof here. The voltages only, it has filtered out only the voltages where it has become zero momentarily. Sometimes what happens is, the meter is functioning and there is a momentary voltage lapse. And while this BLP is getting recorded in the meter, there'll be a zero voltage. So some there'll be a meter will be functional because it's a momentary since there are some supporting batteries and capacitors inside the meter. There'll be sufficient charge for the meter to still operate when this case happens for some moment of time. So at that point of time, this has been recorded. So these are those entries. Okay. So there are other cases where we can inspect here, like KWH jump. So KWH jump is something sudden jump, sudden variation in KWH. So suddenly the consumption is shown that it is very high. So this generally happens when the customer comes disputing that his bill is not correct. Okay. At this point of time, we can know exactly inspect what has gone wrong and what are the things to expect. So let's go to this meter here. So you can see that suddenly this green line, which is KWH, cumulative KWH, it is somewhere in the range of 25. Suddenly it has gone to 15,000, from 1,000 to 15,000. Okay, so it can be clearly seen in this DLP logs. So it is clearly flagged that it's an abnormal KWH jump cumulative. So see, if you can see here, it is in the range of 1,000 and suddenly it has gone to 15,000. Okay. So this is a case, the problem could be that the meter might have gone bad, or it could be also a situation or a condition wherein, there is an excessive load nearby inductive load that has, causing this problem. And Secondly, there is another meter. Let's go into another meter wherein this kind of situation has come up, and this is the evidence where they might have. This is a tampered evidence where they have tried to, you know, uh, tamper it, and in that process, actually, the meter is functioning abnormally and it's showing high current. Right, you can see there are so many tamper events are happened. Okay, if you go to this DLP evidence, so you can see the KWH also has jumped very high. So they have tried to tamper this meter, but suddenly the KWH has jumped in the process and they have messed up the whole thing. The meter is malfunctioning. So there are multiple cases here and conditions here. As you can see, these are pretty much healthy meters which have KW jump. These are all very genuine issues. And this one which is showing a higher KW jump, it's because of a temper. Okay, I will also show a condition wherein there is a RTC drift. So you can see here there is a sudden RTC clock drift detected. So it is drifted by 13 hours. So generally what happens is RTCs usually they try to sync back to the actual time. But sometimes what happens because of the cell inside the meter that would have drained out properly completely, and because of that there is going to be a drift. So you can see the clear evidences here where the HS timestamp and the meter times are different actually. So you can see here the dates and the delay hours. So about 14 hours and 15, 13, 16 hours there is a delay or RTC drift has happened. Okay, this is a clear case of RTC, and you will and the field team will exactly get to check the RTC battery and to replace, and all these instructions are given. Okay. So one another case I will show you wherein it could be like over voltage risk. So something meters that are above 300 volts, exceeded 300 volts, generally they are flagged as high voltage risk because excessive voltage generally causes the meter to get damaged over the period of time because the components inside the meters are rated to only specific operational voltages and currents. If it is exceeds, then the meter will be at the risk. So these kind of things are actually getting analyzed, and you will get a proper insight as to what to do and how to operationally correct these things. So this is another case of a meter which I am taking right now. There is a communication issues which I'll just show quickly. So if you can see in this communication, of course, this is a tempered meter, but I can show you the evidences of communication where the missing blocks are there. So I'll go to this BLP. So you can see here, this is the blog. This is a log actually, and these are the missing blocks, every half an hour blocks. So these blocks are actually missing from the logs. So this is a clear, our tool has identified that these are the missing hour blocks, half an hour blocks, and it has clearly flagged it saying that these are the missing BLP intros. So as you can see, generally speaking here, you can see that this is a digital twin evidence where the meters, all the parameters are plotted and shown here in the waveform. And this is a meter health index. So the user does not have to go back and forth between multiple windows and all that. He can see everything in the same UI. And also if he wants to go see much deeper into it, he can see the evidences that have been raised over here. Okay. So this way the user or the supervisor can very quickly within 2 to 3 minutes can exactly analyze what has happened with the meter and how many meters are there, and he can immediately send all the information to it. So to summarize, we can say that this dashboard actually has analyzed a lot of information, and there are focus areas onto wrong installation, overcurrent, loose contacts, and meter damage. You can also click on these and it will go to the same analysis board. Okay, so this kind of an approach gives the supervisors to exactly prioritize on which meters to target first. Like they will always target with the lower MHI, the critical ones, and then they can prioritize on the higher ones, and then the higher ones, like watch and the degrade. Okay, so this way, what happens? Operational, there will be a operational efficiency will be improved a lot, and in the course of time, a lot of issues like this they start subsiding one by one over the period of time. And thing is that even this has been designed in such a way that even the lower qualified people also can operate, and they will get clear instructions saying that this and this has to be done in their local regional languages. So they need not have to have a expensive degree or anything like that to analyze waveforms and all that. This analysis analytics tool can completely give everybody that freedom to exactly go and chase exactly what has happened in the field, rather than guessing around what might have gone wrong, and which meters to target first and which areas to target first. So this is the major improvements that this tool actually is going to bring. Aspect is, like, we can directly connect this tool to the HES or MDM software directly using APIs. So that person right now, what in this tool, what we are doing right now is we are uploading the customer workbooks downloaded from the HES or MDM, and then the tool is going to analyze everything for you. But now instead of doing that, it can be also programmed in such a way that it can directly access the APIs of HES and MDM and directly access all the data and analyze. So a scheduler can be scheduled in a day, maybe 2 times a day, so that analytics, complete analytics runs 2 times a day, and the dashboard and everything, all the numbers, metrics are updated on a regular basis. Aspect is, so as I have explained you entirely, so with this we can achieve up to 95% of prediction accuracy. So across there are multiple four critical problem categories. That is meter tampering you can achieve. As we have already seen that there are CT open cases, phase reversal, bypass links, then B phase reversals, R phase, and all those things. Okay, and this is in combination with the events and DLP evidences. Second thing is terminal block issues, wherein there are loose connections, loose contacts, contact burnouts, intermittent voltage drops, those things. So that can be easily flagged. The third thing is the RTC drift. Generally, it is caused by either firmware or the battery issues. So that is easily exactly flagged, as I have already shown you that there are about 13 hour differences in some of the cases there. And communication failures, as I've already demoed it in the tool, that there are about these many blocks that are missing. So with this, as and when the corrections are going to happen and the platform optimizes, the data volume required also will get reduced in the storage. See, as meter sends out these events, okay, it sends the events based on some of the anomalies in the meters. So if you start reducing the anomalies in the meters, the cloud storage that is required to store these event triggers or event logs will get reduced, and hence the cost of the cloud will also come down. And it's going to be this tool is a big impact to the field team. Basically, it is like you are prioritizing which meters to target, where to go, which area to visit, and it's going to be like there will be fewer unnecessary trips, so which will reduce the costs, and basically it will be a right fix for every first visit, right fix every time. So this is going to be a targeted approach or delivery to the correction of the problems. And as I've also mentioned that this tool or this platform is very good for even the low qualified people also, uh, where they can easily understand what to do exactly when they visit the fields. I really thank for the team to giving us this opportunity for Teknovate to present this, and this has been a really honor to work on this kind of a project, and we will be really happy to deploy this tool into your discoms. or wherever you are. Thank you very much. Thanks for the opportunity.